Okay, so in this problem, we are asked about depreciation. We're told that the value V of a Chevy Cavalier coupe that is T years old can be modeled by V as a function of T equals 14,512 times 0.82 raised to the power of T. And you're asked then, according to this model, when will the car be worth $9,000? All right, so my V as a function of T is 14,512, which actually represents the initial cost of the car. That is, when T is 0, you're driving the car off the lot. The value of the car is 14,512. And it's depreciating. This term is 0.82 times T. So every year that passes, it's worth 82% of what it was the previous year. So we want to know, when will it be worth 9,000? So our V of T is therefore 9,000. And so I'm going to let the left-hand side of my equation equal to 9,000 equals 14,512 times 0.82 to the T. And I'm going to solve this equation for T. Just a note here, be careful. Many students would start by taking the logarithm of both sides and then bringing that T down here to the front. That would be incorrect. The T, the exponent here, is only on the 0.82. It is not on the 14,512. And so the first thing I'm going to do is I'm going to divide both sides by 14,512. I'll get 9,000 over 14,512 equals 0.82 to the T. And now, because my exponent contains my variable T that I want, I'm going to take the logarithm of both sides. And what I'm going to do is I'm going to take the logarithm to the base 0.82. So if I take the log to the base 0.82 of the left-hand side of 9,000 over 14,512, and on the right-hand side, same, log to the base 0.82 of, my argument is 0.82 to the power of T. And now I can use my rules of logarithms to bring my T down here to the front. And so I will get, just rearranging, I'm going to write T, what's on the right, I'm going to move it to the left. So T on the log to the base 0.82 of 0.82 equals the logarithm of 0.82 to, my argument is 9,000 all over 14,512. And now what I notice is that this part here, log to the base 0.82 of 0.82, my base number and my argument are the same, and so this here is equal to just 1. And so what I have is I have T times 1, or just T, which is what I'm looking for. So T is the log to the base 0.82 of 9,000 divided by 14,512. And I can work out my T using my calculator, which I will do. 0.82, and I have 9,000 divided by 14,512, and I get 2.407, so approximately 2.41 years. And that's how we do that sort of a problem. I'm going to just do one more using the same function. According to the model, when will the car be worth 4,000? So let's do for another part here. So when will it be worth 4,000? Well, it's the same equation. The only thing that's changed is I have now gone from 9,000 here, if you like, 9,000 here. I can just replace that with 4,000. and everything else is exactly the same. So when will it be worth 4,000? Well, t will be log to the base 0.82 of 4,000 divided by the initial price of the car, which was 14,512. And my calculator tells me that that is 6.493. I'll take 6.5. So approximately 6.5 years. And that is how we use logarithms and the rules of logarithms to solve for our variable when it is in the exponent, like in a problem like this.